just to completely drop that and move straight on to something else. No, just kidding. There's more than one way to the top of the mountain. I don't mind what technology you're using. Hopefully we'll get some ideas out of this. I'm not going the web route. I'll champion the reasons behind that, but that doesn't mean I'm rubbishing anything else. It's just, I'm just going to give you my point of view and why I'm doing certain things.
Sorry, Steve. I just forgot to tell people we are recording these sessions on video, so if you come out the front and your pants fall off or something, it'll be online.
It's not live streaming, it's just Steve.
It's not live streaming, we can edit it later.
Okay, so just before I kick off, I've shared a bunch of resources through a OneDrive folder to all the teachers who work in EQ. Those who don't, if you want access to that share after the talk, just email me with a Gmail account. It may be your school account if it's handled by Google, but it may not be as well, and I can add you to that share. In the meantime, I have everything on this USB stick because I figured, even if I did manage to add you, Google Drive's blocked by the EQ network anyway. So yay for EQ network. So can I hand this around to anybody who hasn't already got access to the folder or wants a local copy? You guys can just pass that around and copy everything off it.
Steve, what's your email?
Sorry?
What's your email?
Oh, yes, okay. I'll put that off there. Why not? Okay, so that's my email if you need it. Okay, so we're here today to talk about Unit 2. We're supposed to be here to talk about Unit 2. I'm also going to be talking about Unit 1 and Unit 2 and how it's going to feed into Unit 3 and possibly a little bit about Unit 4. Okay, so you're all here for Unit 2 and you're going, what the? So I think that deserves just a quick little explanation. So at the end of the last year, I gave a talk about some tools that I'd written. So I'd written a bunch of software tools because I saw the need to scratch my own itch. I wanted to help the students in my school. I didn't find tools that did exactly what I wanted for the path that I'd laid out. So begrudgingly, I decided to write a set of my own tools. So I've done that, and I've open sourced it, and I've made it available to everybody, whoever wants it. So far, last count, I think I had 140 odd teachers across Queensland request the materials and being granted access to it as well. But anyway, I gave a talk about moving that progression from having never coded at all into text-based coding, moving through up until object-oriented, event-driven programming, using games as our vehicle to get the interest by students. The games aren't something I'm particularly interested in, but kids seem to like it, so I wrote a framework for writing simple games in Python. After that talk, I was asked by Talia if I could come up and present to you guys. Unfortunately, with the time frame, we couldn't make that work last year. So I was able to make it here for Unit 2. So hopefully that gives you some explanation of why I'm talking about Unit 1 stuff. There's lots of, if you've noticed, there's lots of PowerPoints around the room. So I figured you didn't need another one. So I scrapped all my PowerPoints and you've just got me up here pontificating. I actually, a few days ago, I looked at it and I went, this isn't working, and I scrapped the whole lot. And then yesterday I was freaking out, going, I've written it, rewritten it, threw it out. And I was saying to my wife, I'm still not ready. And my daughter overheard, she's in Year 9, and quickly took the opportunity to run out and say, oh, you didn't prepare? Yeah, so I've sort of hammered her with starting early, getting prepared. Anyway, but I'll explain why that is. So just before I roll into it, the way this has sort of come out and evolved, and I'm hoping to get this sort of attitude, I think I'm preaching to the choir because you're all here today anyway. We always tell people to be lifetime learners, and I'm seeing that a bit with teachers. Some of them are really inspiring, and others I'm not seeing it so much. So I'm sort of, even if this is in your area, I'm hoping in some way to inspire you to learn something new too. I think this new syllabus that we've got is wonderful, well, definitely compared to the old one. It's given us an opportunity, and I really believe that we can lead the country in IT with some of the things that we're doing. So just to give you an example of what I mean by some teachers inspiring me, is when I started out, I come from a university background, so I lectured computer science for a number of years, And then I went into industry as a computer programmer, eventually for a short period of time, Chief Technology Officer of a software development company. Wasn't my cup of tea. I missed uni, I missed teaching, and I went, oh, let's have a look at high school. So I ended up doing that, getting into high school, and then the new syllabus came out, and I looked at it and I sat down and went, okay, how am I going to map this out? One big thing I noticed is it's no longer silos. So we don't teach this, forget it, teach this, and everything's its own unit. So one of the reasons why I'm covering a couple of units is because that's the way I progress the whole thing. One leads into the other, one joins the other. In fact, right at the end, I'll show you what my students are doing, and it's essentially one big project. So it's modular, but it's not silo, and we work from one thing into another. And when I was talking about, when I was looking at the syllabus, I planned it out and I started writing some tools. It was very, very early on. I took Python Turtle, and I thought that's a great starting point, and I wrote some coursework around that. That got to a certain point and I went, that's not really filling my needs now, and that's when I had to start writing software myself. And I wrote a framework for gaming in Python. And when I went to the QSITE workshop down on the Gold Coast, I had this USB stick with me, and I thought I'll share this with whoever wants it. And so whenever somebody asked, do you have resources, I gave them a USB stick seeing what would happen. And it was very early days, early version of the framework. And one teacher at Marymount, Kylie, she came around, she was running around asking for everyone for all different resources. She was just open to everything. She wanted to see what everyone was using. She wasn't sort of stuck in one technology, or this is what I've done for the last 20 years. She just wanted to know what was out there. I gave her my stuff, and she went and got a bunch of other people's stuff. I heard nothing. The next day she came back and asked me a little bit more about it, and then she went off to digest that, and I didn't hear anything else. And then one day I got an email. She said, I've got a question about one of your exercises that I'm doing with my students. I looked at it and I went, hold on, you must be 3 or 4 weeks into this. And I got a hold of her, and she was. She looked at it, she decided that it made sense, that it did what her students needed it to do, and she had no idea how to do it, but she jumped in with both feet and did it anyway. And she learnt along with the students. And that absolutely inspired me in a big way. Because it's easy for me, like when I talk to teachers that I've helped and they've got their coursework, I say, wow, you've really inspired me. And they say, well, how could I inspire you? Look, you've created all the software, I'm just using it. Well, that's not it at all. It's easy for me because I've come from a university background. The technology side's not my challenge. Working with these crazy alien-like people we call adolescents or teenagers, that's my challenge. Technology isn't. What inspires me is someone going, I don't know this, but I'm going to have a go and I'm going to jump in. And the reason why I'm here today is because of Talia. So she came to that talk down on the Gold Coast as well. Also had the same approach. When, I don't know, you haven't done much Python prior?
Like 6 months.
Okay, so certainly not object-oriented game development, event-driven software. And you're running it right now. And last week you went and installed the system across, or this week installed it across all your lab, have all your students up and running. She's created a game herself, and she's up and ready to go. So she's now got these extra skills. And I just want to acknowledge that, because that's why I'm here. That's why I got up at ridiculous and got the old jalopy and made my way up here. So what we're going to step through is, hopefully a few people have got that USB stick around now. So I'll just explain some of the stuff I've got here. Alright, so this folder here is now shared to lots and lots and lots of people. And this talk is going to be kind of like one of those annoying movies, you know, where it starts off, it gets to a certain point, and then it does a flashback to 3 years prior to where the movie starts, and then it works up until it joins the current moment, and then we go forward. Yeah, that's what I'm doing, so buckle up, pay attention. Alright, so this is basically the group of software that I've written. Now, to put it in perspective, I've planned digital solutions from year 9. Okay, so the level, like I know my guys are working at the moment, can't happen in a couple of weeks before they get their first assessment piece. So I've planned it from year 9. Now that doesn't mean you can't use this stuff starting in year 11, sorry. Talia's doing exactly that. But it was planned from year 9 upwards, so that when they hit year 11, they already had a set of skills that they could run with. So that was the layout that I had. So I start off with very simple programming using Python and Turtle, which I'll show you shortly. Turtle's basically just this little arrow on the screen, you make it go forward and turn left. And we slowly build up. And I've now done it successfully with 6 different classes. And I average about 6 or 7 weeks to go from zero coding at all to writing object-oriented, event-driven Python programming, creating games using objects and moving them around the screen. Real code. All right, so just a quick run through this. We go from the turtle unit, then we go to GameFrame. So GameFrame, I've already mentioned, is a framework that I've written. It sits on top of Pygame. So some people, some teachers I've seen in previous talks, like at PyCon and so on, use Pygame. I looked at it and I just went, there's too much there that is not what we're focused on. So they've got to do a whole bunch of stuff. They've got to have their game loop and they've got to handle the collisions and they've got to do a whole bunch of stuff that's really not our core objective. But it seemed like a really cool thing. Kids enjoy writing games. So I wrote this framework and I was kind of inspired by GameMaker. Quick show of hands who uses GameMaker. So, okay, so most people know what I'm talking about. And so I've got a concept of you create a room and you create objects and you handle those objects in the room. But it's all text-based. I didn't want to use GameMaker because people tend to have this fallback position. I can't get the code to work, I'll go back to the icons. Absolutely did not want that. Okay, so it had to be text-based. Also, just to let you know, I write text-based code from year 7 upwards. So we start with Edison Robots, which is Python. I then go to, where's my core gone? Is that robotic? Oh, it's just behind you. Would you be able to bring that up for me? They're Edison robots. Yeah. Thank you. So this little board here is called a Pi board. So when I first started at Varsity, they were using Arduino. And you know, Arduino is good, it's open source, it does a lot of really cool things, there's lots of good resources. But introducing someone who's never done programming to a C-based language straight away I find it's problematic. And trust me, this was a painful transition for me because at university I was like, if you use Python, that's a sign of weakness, you must write in C. Okay, and C++ I might put up with, but you know, real programmers program in C. But when I got to high school, you know, you've got to adapt to your audience, and I felt like that was too much of a leap to do straight away. And quite honestly, in university, we wouldn't jump straight to C either. So I found these Pi boards, and these are really good if you've got Arduino kids and you're finding the same thing. That it might be a bit of a jump, because all you have to do is pay $22 for one of these boards, stick it into your kit, throw out the Arduino board, or put it in the cupboard, and you can still use all the same kit and all the same stuff. So I've got servos running in here. So I'll just give you a quick example. There's a ball here, but I'll just show you the movement. So this one's programmed to pick the ball up from there and drop it up in here. We 3D printed all the parts, put it together with some servos, connected it to the Pi board, and I had that programmed in about an hour. That was only because I was struggling to get the coordinates. It's super simple. There's no semicolons, there's no curly braces, you don't have your setup loop and your main loop. It's just a simple Python code. Okay, so I've really gone the Python route from year 7 right through to year 12. But anyway, I'll continue on. So that's the game frame, that's where we get up to that point. This is the section that we're really, I guess you're here for today, is my query tutor. So again, when I got to the teaching SQL, I looked at the tools, and look, there's good tools. I'm not rubbishing any of the other tools. That just didn't quite have the things that I wanted. So there's IPT Online, and that has a system where you can put in your queries, and you've got a set of questions, and you can move through that. It's good, but it doesn't tell you if you're right or wrong. You just get the solution. You also get to see what the proper solution should be. It doesn't tell you how you got this query wrong, or give you any idea of where you got it wrong. There's the W3C site as well, which again is very good, but there were certain things that I wanted to build into this that weren't available. So I've written that as well, so I'll come back and have a look at that. Capture the flag I probably won't get to today, but it's there for you to look at. I'm running a competition across schools towards the end of the year, and basically what that is the next step on from GameFrame. So once students can write games in Python, one day I was sitting down, middle of second semester last year, and I was helping one of the students do his rotation of his character and movement, and we started to get this natural flowing movement, and then it just dawned on me. I thought, oh, why don't I write a game, not a game, why don't I write a platform where students control autonomous bots, these virtual bots, and they can do a capture the flag. So you start on your own side, you cross over and try and get the flag before they tag you, and you can just program these little bots. So we built up the skills with object-oriented programming, with text-based programming, and then it's just all about algorithms. Because once you're doing capture the flag, it's just algorithms, algorithms, algorithms. And they're doing some pretty cool stuff, actually, if I can get back to that. All right, so I'm going to start from Unit 2. I'm going to jump back to Unit 1, work up to Unit 2, and talk about Unit 3. Okay. All right, so there's this thing here, My Query Tutor. So inside that folder, does anyone run Macs? Anyone got a Mac? Oh, this will be easy. Okay, so there is an installer for Mac. It's the bane of my existence. The Linux installer took me about 20 minutes. The Windows installer took me about 2 hours to get right. And after 4 solid 6-hour days, I pushed out this horrible, massive, horrible installer thing, but it works. So if you're on a Mac, you can use it. All right, so the important thing is here, I've got a user guide, I've got the executable here to install, and I've got these ERDs that go along with it. So just to let you know, I've got this program working at a level that's completely functional. I used it last year to teach SQL to my Year 12 students. I will be using it as is for my Year 11 students starting in Unit 2, but it's far from complete from what I want. So there's lots and lots of things that I want. So if you can go ahead and install that, and I'll just stop for a second for the sake of the camera. Because I'm so limited on time, I'm going to go through these things and hopefully you can follow along. The reason I bought the camera is rather than get tied up, someone might have a problem with installing or something like that. If you hit an issue and you can't get through it, if you could just follow along with somebody else and we can look at the camera later on, I'll upload it to YouTube and you can watch it as many times as you want and get over any of those problems. At lunchtime or whatever, I can sit down and help you, but I'm just trying to push through so that we can get through the content. All right, so if you have that in front of you at the moment, if you could install that, just install it as a local user. It asks you if you want to do it for everyone or just the current user. Please just do it for the current user. The user for everyone is something that I'm planning and it hasn't quite got there yet. And it's mainly to do with stuff in the back end. So it's not ready yet for lab environments, but I plan to do that very soon. So it can be a multi-user system. At the moment, it's just for the person who installed it. So if you can install that, that'd be wonderful.
Is that USB still traveling around?
Yeah, it's over there.
Just doing the round.
Okay, so just to tout the benefits of this. So I've got this desktop application. And I'll just talk about some of the design decisions. The reason it's a desktop application and not a web application: 1, I don't have to run a server. 2, if your Wi-Fi is flaky, it doesn't make any difference. I didn't want to walk into a classroom and go troubleshoot for half the lesson people's network connectivity issues just so that they can get onto the content. So worst case scenario, I just walk up, give them a USB stick, install it, and then they're up and running, and it stays on their machine where it tracks their progress. Okay, so what we have is when we launch this application, this is written in Python using Qt with an SQLite database, and that's really important, and I'll come back to why that's important. But what we have is we've got different topics for SQL down the left-hand side here. So we've got select statements, where, order by, aggregates, group by, joins, and subqueries. So these are the things we want them to go through. Now, because it's local, I've got this really big thing with not limiting students. So I want to help lift them up, but I never ever want to be the ceiling that stops them doing things. Again, if this was web-based, I wouldn't be able to let them do things like SQL injections. If some students, and occasionally I get 1 or 2 that are quite advanced or become quite advanced very quickly, some real smart boogies, they can mess this up as much as they want. Because they're only playing with their own machine, we can wipe and give them a new database. whatever. So they can actually do any sort of query that they want on here without fear of breaking things. So on the left here we have all these different sections, and in there we have questions under each section. So I do have a version of this that's far, far prettier. It's got animations, things whizzing around, and the idea was we were trying to make learning SQL interesting. So we wanted to work through a pattern where you're investigating a crime. And to begin with, you want to find all the people that have size 8 shoes or whatever, because you found a size 8 shoe pattern. And you slowly build up the queries until you get to the end and you have some quite difficult query to figure out who the villain actually is. That was the vision, and we wanted it all to be interactive. This section here is actually a web view, so this part here is programmed in HTML, CSS, JavaScript. So if anyone is good with those things and wants to contribute at the end of this, please let me know. Now, I said I did have all that cool interactive stuff, but sadly I found out I didn't do that. I did the rest of the program. Somebody else was doing this, and I found out there were some things in there that weren't original and weren't licensed appropriately. So now I've set back to a very basic version, but all that stuff will come back. But I just cannot risk using images or anything like that that we didn't create or aren't licensed appropriately, because I want to have confidence that when I give this to you, you can do what you want with it. Okay, so for instance, we've got this question here. I've already got a query in there from the last time I ran it, and I've got some buttons here. So here's the question up here: write a query that will return all the attributes of information from the continent table. And we work through a I do, we do, you do progression. So the first question, I just tell you how to do it. This is how you write the query. Just all you have to do is write it in there and hit go. Then we do a sort of a we do, where I give you a partially completed query and you have to correct it or extend it. And then we got questions that just straight out, I need this information. Get it out of the database. So there's a planned progression through these, both through the types of queries as well as the difficulty within the queries. All right, so it says there, first we start off by using the select keyword. So, okay, put select in there. After this, we can list all the column names, or instead just use an asterisk. So we'll do that. Press enter for a line break. Obviously that doesn't matter, we could have kept going, but we want it formatted nicely. Follow this by typing out the second keyword from. Finally, we write down the name of the table we want to select this data from, continent. So back in that file where I showed you, where we have all the ERDs, all these questions relate to the different ERDs. So you can look at it and you can see what the table names are and all the rest of it. So you can do that. All right, so let's have a look at these buttons. First of all, let's see what we would expect to get back if our query was correct. So if I hit expected result, it shows me what the correct result would be. So that's what I expect to get back. Okay, so I'll just pop that over to the side. Now I'm going to run the query, which will run whatever text I have down here. And I get the green light and the little celebrating person down there with his arms up. Didn't figure out what that was. Yay, correct. And all the text is green, okay, because I got the query right. If I can compare the two tables, yeah, they look the same. So what's really important with this is that instant feedback loop, and it's self-paced as well. So quite often I'll give this out to the class, and I'll have one or two that will come in 2 days later with every single question completed, and I'll have other people that need help and get assistance during class. So a few years back, when I was working at university, wrote a research paper and wrote some software on basically feedback loops for learning. So we wrote this software that was to teach coding, it was Java at the time, and it tracked all sorts of things like what time of day were they doing the queries or writing the code, how many mistakes, how many times they could compile till they got it right, all these sorts of things so we could adapt our teaching to their learning. It did go into some schools down on the Gold Coast for a while, for about 2 or 3 years. It ended up failing miserably because it had so much network activity. So I've really made sure that this has no network activity. But my plan in the future is to give you all that information and statistics so you can adapt to your learning. It's not there yet, but what it will probably take the form of is it'll keep all the information there, and then you might say to your students once a week, hit this button and it will send you the information. So it's not constantly polling or trying to talk to a server or anything like that. And I might just do it via email maybe. I'm not sure. But if you guys want to give me input on how you'd like to get that information, I can certainly code that in the way people want it. Okay, so we've got our query down here. Let's say I do this, I spell that wrong, and I run the query. Okay, I've got it wrong, and you can see I've got some green text here, and it tells me this is where my error is. This looks really cool at this point. When we get further along, this was only our very first naive little algorithm to check where things are wrong. It's not really that reliable, but it gives them an idea. Again, I want to work on that algorithm and get this working, but I just didn't have time. And up the top there, we've got our error. This is just straight out from the database, so whatever the database spits back as an error, that's what I actually display there. So we've got it wrong there. I'll put that one back in. Run query, and it's correct. Okay, so now that I've done that, I want to know the progress of my students. At the moment, it's not automated. It doesn't just come to you. That's the future plan. But what I do is I just say, okay, everyone, hit your progress button. I'm walking around the room. Grey means I haven't attempted any query, so I haven't hit run query on that question. Green means I've hit run query and I've got a successful query. And the orange means I've hit run query, but I haven't been able to get the question right. So I just say, everyone hit progress button, walk around the room. Within about 30 seconds, I've got a good idea of the progress of all the students in the room. And particularly, if I've got a whole bunch of oranges here, I know today I'm going to talk about aggregates, because everyone's having a problem with aggregates. I'm not going to talk about where, because everyone's got green lights on the where. Everyone's got a good understanding of that. So it's a really cool tool. So these are some of the things that motivated me to write the software myself rather than use existing things, because I wanted to tailor it to us, to the things that we actually need, and that one's just a killer feature that I had to have. Okay, so if I'm in one of these topics, whether I'm in select or where, let's say I go down to where, and I hit topic lesson, so whatever question I happen to be, the topic lesson will adapt to being that topic. So because I'm under where, it gives me the lesson on where. So here it goes through and explains, it's got an ERD there as an example, and it goes through and explains what it is and how to use it. So again, I wanted this tool to be something that they could use away from the teacher. Some students, I know I was one, I couldn't work in a busy classroom, there's too much noise, too many things going on, too many people doing interesting things. I'd go find my own quiet little spot at home or something and I could work through this. And I've got some students to do that, I've got other students that only work in class, so it's available to them no matter what. Interesting thing from when we wrote that software for university, and again this is adult students, not high school students, is when we graphed out the time they did the work, we had a 2-hour tutorial time, and that probably came up about that much on the graph. The amount of time done at home was about that. Time done after 10 o'clock was the majority of that column. It was crazy. I don't know why they'd pick after 10 p.m. Maybe their lives are really busy and, I don't know, maybe mum and dad turned Facebook off at 10 o'clock or something. So then they started doing it. So it was really important to me that they could, if they were motivated, sit there and read through the lessons. Again, my vision for the future is we'd have embedded video tutorials as well. We did that with the software we wrote for programming. So they could come in here, they could read it, they could watch a video, have it in different formats, have a worked example maybe, something like that, and then report all that back to the teacher. So that's where I'm going with it. So at the moment it looks really, really plain. Tali, you remember what the other one looked like? Tell everyone it was wonderful.
Yeah, it was really cool. Yeah, definitely. It was like, sort of, the kids, it looked like they were playing a game, really.
Yeah.
Like they were just playing a game to solve a crime, and yeah, every different lesson that they went to was like a different briefcase opened, and yeah.
Yeah, so we had lots of cool stuff going in there, but again, once I found out some of the material wasn't original, I just couldn't use it, so I rolled back to an earlier version until we can solve those problems. But that's all in the pipeline. Okay, so that's the basic functionality of it. So we step through there, we start doing between clauses, yeah, the aggregates. I won't go through all that because you guys can step through it. but that's the basic concept. It's all packaged up into a desktop application. Network's not going to affect you. It's got all the information in the topic lessons. You can see their progress, and they can work through it from top to bottom. Okay. So the reason why I started with that tool is I think that will tick a box for everybody in the room, whether you're doing web-based or you choose to do the right way and do a desktop application. This should be common to all of us, I would think. Yeah. So just a quick show of hands who thinks this might be something useful that they'll use in their classroom. Excellent, excellent. Okay. So if everything goes down from hill from here, just remember this part of the talk. Okay, so moving on to starting Python. And again, even though I joke about it, please don't think I'm trying to offend anyone. There's more than one way to the top of the mountain. Whatever technology you're using, if you use it effectively, it'll be a wonderful tool. I'm going to champion my direction and why I did it though, so please keep that in mind. Okay, as I said, before I came to secondary education, I never used Python. I think I'd written one small program in it, decided I didn't like it. Python was for the weak, and I went back to my general languages that I used. But then I was working on high performance computing clusters, so if you weren't in C, you weren't really in the game anyway. When I came to high school, I looked at it, I looked at what the learning that they needed was, and I wanted to get as many barriers out of the way as I could. And Python really did that for me. When I started with the Arduino, and I was watching the kids do it, and they get caught up on a curly brace or a semicolon, is that really the learning that we care about? Not really. The syntax is secondary. If I can get them up and running quicker on a simpler language, so we can really start concentrating on the algorithms and that programmatic thinking, then that's what I cared about. And Python really fit the bill for me there, and that's why I ended up going down the route of Python. Now, I haven't been a JavaScript person either, so maybe JavaScript's just as good, I don't know. But I really find Python is really good for my purposes. So I started out with Python, and I wanted some basic tools. Now, everything I've made is completely free, open source licensed. I did it. The programs, not so much the content, but I'm getting clearance for that. All the programs are 100% owned by me, not EQ. I made sure of that. In fact, at the time when I made them and licensed them, I wasn't actually employed by EQ. Even though the vast majority of development has been done as an employee, it doesn't matter because it was written and licensed under one thing and it can't be changed. So I own it, I've licensed it, I've checked it with the lawyers, and I'm giving it away to everyone to use however they like, which means you can change it. One thing I forgot to mention about the database program is I will be writing, I don't know when because I'm writing so many things at once, one day I will write a really easy application for a teacher to be able to add questions and remove questions. So you can tailor it to however you want. So you'll need to put in the HTML for the question, or I might even automate that. I'll just say pick a template where you put in the question. I'll need the SQL answer because it actually runs that SQL to show you the answer. And the reason why I do that is, let's say they go run a query and actually remove or add something from the table, I will still want it to be correct at the time they run it. So my query will match their query even if the data behind it has changed. So when it comes up with the answer, that's not hard-coded, that's actually querying the database and showing you the result. So if you took the database away or corrupted it, all the answers wouldn't work as well. Okay, so you put in the questions, you put in the SQL, that's the correct SQL, or an exemplar, because it's more than one way of doing it. And then you could add that. And so I'm going to write a tool to do that, but in the meantime, if you are technically minded and you don't mind jumping into an SQLite database, you can just manipulate the data directly. So you can change all of that. I wrote my query shooter so it adapts to the data. So that all those menus and everything you saw, that's not hard-coded either. That reads from an SQLite database, says what are my menus, what are my topics, what are my questions, and it builds the application from there. So if you want to go change the database, you can change the whole application. And that's the way I've approached all my tools and materials. So when we use something, I don't want to go too much into it. There's another video from the talk I did at the end of last year that does go into depth as to why I chose the tools and how they work. So I'll just direct you to that because that's a 40-minute talk on itself. So I'll just say I've written it so that you can edit it. Some of the problems I had with existing tools was some of the tools were great. So let's say we looked at IPTO for our database to learn SQL. I could look at it and go, okay, pretty good tool, does a lot of things, maybe doesn't tick all the boxes I want, but do I really want to go write software to replace it? This is my thought pattern. Probably don't. Well, let's have a look at it. Okay, that's really cool, but I'd really like to change that question. I'd like to change the order of that. Wouldn't it be cool if we had some extra stuff? What do? I could write to him, cap in hand, and say, hey, could we please add this? Might not, might disagree with me. Whereas if I have my own software, I've got access to the source code. All of this is on GitHub. For those, again, who are technically minded and want to drag down the source code, I can have my stuff changed for the next lesson and running. I don't have to ask anyone. I can adapt it to my students the way I want. And I wanted that for everybody else as well. So you've got access to everything. There's nothing hidden. You can tailor it to your students however you want. That was another big reason why I ended up writing code rather than taking existing things. All right, so I digress. Back into the Python turtle. So this is where we start. Now again, I aim this, if you have the luxury of going through the progression, I aim this for year 9. If you don't, last year when I had year 12, I walked in, I didn't have them the year before, and I walked in and said, okay guys, I need to find out where you're at. Any language, I don't care what it is, somebody come up here and do a loop that loops 8 times. Didn't have a single person in the class starting year 12 to write a loop. And so after I picked myself up off the floor, wiped the sweat off my forehead, I took them back to the basics. And in 1 year, I had a year 12 class go from absolutely no capability whatsoever, right through and completing year 12, and some of them getting BHAs and writing some quite impressive programs. So in the game frame, one of them went, oh, I'm going to do a flight simulator. And I went, oh mate, you're aiming too high. That was my first lesson in not putting a cap on students. He did. He wrote a flight simulator and it was really, really cool. And another guy did a tank battle where it went around an arena where the arena spun, and he had some pretty hairy maths in there. Lucky he was a good maths student. So yeah, they could do that. All right, so in Python, if you need to start this in year 12, it's not ideal, but if you're in that position, or year 11, if you're in that position like I was, you certainly can. This should take you about 5 weeks to get through for, it's pretty much the lessons.
For a year 9 student.
For a year 9 student, it's about 6 weeks, an extra week or 2 for year 9. If you're in year 11, then yeah, definitely no more than 5 weeks. So yeah, I normally have them on the game program by week 7 in year 9. Okay, so if we have a look in here, I've got an exam there that you can take. Now, I already know teachers who have taken this, changed it to what they wanted and given it to their students. They wanted to get rid of some stuff and add some other stuff to cater to what they wanted, and you can. That's why I've supplied it in a doc format rather than just a PDF. So you're free to change that. Now these are the units. Now I'll just show you what goes into a unit. If you go inside that, which you all have access to now, there's student files and teacher files. I've got a lesson plan. Again, that's in ODT because I did it in LibreOffice. 90% of my time I'm on Linux, not Windows. So occasionally I forget to convert it to what everyone else uses, the docx. But that opens in Word anyway. So you won't have a problem, that'll open up. You can edit it and create a new PDF if you like. So that's the PDF, that's the editable file. I've got student files and I've got teacher files. So the student files, I've got a worksheet. Okay, so this starts 101, what is Python? And the students work through that worksheet. And we help them out. So the very first thing is just a hello world. I get them to create a folder structure to keep everything, because I give them all the files for each lesson, all the exercise files, and what they do is they edit them. And I get them to submit every single week, all their files. And I'll show you how to do that without it being a pain or being a lot of work for the teacher. And then we start on actually running Turtle. So I won't spend a lot of time on this. This is the basics, and if you're not familiar with it, you can work through all these. That's what most teachers do if they don't have a background in this. rather than go, I can't do this, it's too much, they actually just work through exactly what the students work through. And they get up and running pretty quick. You ended up doing the Veggie Samurai, which is a game frame game, fairly quickly. I think when you went through it, you did it in like a day from what I could see.
Yeah, it was like in between classes when I
Yeah.
just keep.
Alright, so what I'll do is I'll just run up idle. So if you have Python installed, I'm running 3.7.0 for a reason, which I'll come back. That's really important for EQ teachers. If you're not in EQ, you can probably just grab the latest Python if it's easier. But that's important for us, I'll come back to why. So if we've got Python here, I can run commands interactively here, because this is the interpreter, so if I just type something, I get hello. So if you've got Python installed, you can launch IDLE, I-D-L-E, it comes with Python, and it's its own sort of little development environment. It's not a full-blown IDE, but it's an editor and an interpreter. So I can run commands directly in there. But what we do is we use the editor. We can use the interpreter for testing things, but if I create a new file there, I explain to them it's just like creating a Word doc or something like that. You open up the program and save the file somewhere, but then we run it as a program. So it'll actually execute. So I'll close that one. And I give them a few lines. I give them the import turtle, and I explain that what we're doing is getting access to code somebody else wrote, and that's what the import line does. So we've got access to that code now if you want to use turtle, and I'll create one. All this code's given to them, they don't have to create this part. Okay, so at this point, actually I'll do one more thing. I'll get the turtle to drive forward. Okay, at this point, lesson 1, day 1 of the course, we're importing code, and I explain that. We're using an object, creating a variable, assigning an object that we've created, and then we're using a function within an object. And I use that language. Okay, so one of the things I use, well, one of the things I believe in is if you have complicated terminology or complicated concepts, introduce them early and repeat them often. So at this point, they're not really going to get it when I say that this is an assignment, that's an object, this is a function call, but they do. They start to get it very, very quickly if I keep using that language and I explain what it does. So here we go, we're running this. If I go run and then click run module or just press F5, I have to save it somewhere. I'll just throw it on my desktop. Okay, so it's done what I've asked. This little thing here is the turtle. It started in the middle, facing to the right, because our coordinate system is this is 0 degrees. Okay, so to the right is 0 degrees, and then it goes around the full 360. And you can give degrees to turn and so on. So if I wanted to draw a square with this turtle, I'm not feeling the turtle love, so I'm just going to change it to be an actual turtle. Okay, so I might say, okay, well, how would I make a square? I've driven forward, I'll turn left, 90 degrees. Okay, so then I have to go forward again, turn left 90 degrees. So what I end up writing is a whole bunch of repeated code. Press F5, save that. Oh, okay, just put turtle wrong or something. Maybe it's a lowercase t. If that doesn't work, I'll get rid of the turtle. There we go. Alright, so I've just changed the shape. It's a little bit more fun. So you drive forward a certain number of pixels, you turn left by a certain number of degrees, and you go around. And that's the level that we start at. So it's very, very simple. All I say is use my TTL is the label I give it. Explain it could be anything, but that's the label I've given to that object on the screen. So again, I'm talking in objects and functions. When I want it to do something, a function, I say the thing that I want to act on, my turtle, I put a dot and I give it an instruction, which is a function. So my turtle forward, it drove forward. Okay, and you can get a hold of that pretty quick. That's usually not a barrier. All right, so that's where we start off. And then we slowly progress. I'll show you the net. That's a whole lesson. They've got to go create a bunch of different shapes. Then they're instructed to go and make a shape of their own. That's lesson 1. Okay, after that, we start getting to other things. And we say, okay, we want to draw a square, and we don't want to repeat all our code. Okay, and now we're starting to program. So I let them make that mistake, and they've got to go write their own really cool shape, which ends up being a massive amount of code, and then I showed them the loop so that they can appreciate what they're getting. And if we go back into, the folder, go to lesson 2. Oh no, I haven't included it there. I will come back and add that to the shared folder. I'll just go in here and grab the ones I've got. Okay, apparently I didn't include it there either. Damn live demos. Okay, so I'll just explain what I've got and I'll update it for you later. My apologies. Actually, I might just check one last spot.
You want your USB back? I think it's on there.
Yeah, no, I'm looking for the videos and I'm just taking
they're on there.
I think they're in, I saw them before, I think they're all in number 1 inside
There's 2 in PyQt.
teacher files introduction.
in here.
Yeah. Those ones down the bottom.
Oh, right, okay, they're there. All right, so this comes along with all the different concepts. So in this one, for instance, I've got 2 videos here to teach the teachers. So if you are new to this, when I originally wrote this, I was writing it for a school that didn't have an IT teacher and I wasn't going to work there. And so the first few lessons, I actually included videos for the teachers so they could learn the concepts and teach them as well. So if I play one of those videos,
welcome to the first teacher's video. What
and I'll just skip through.
to be ready to go. So they can start coding.
So it goes through using the tools, what all the different
Okay, so that's
files
the
are.
outline. So let's have a look at the PowerPoint.
Okay, so all the resources are there, and the students should also have their own video, which is separate to these ones. Damn, that's annoying. Okay, what I'll do is I'll actually bring up the site. Currently at the moment, I'm running an eLearn website across 7 schools. So we've got 7 schools all running this program. And so I'll just show you the website, it'll be easier. If anyone wants to join this, by the way, that's in EQ, just send me an email and you can just enroll all your students and you can work through all the coursework. So it's all there, it's already laid out. It's all available to you. If you're not in an EQ school, I do the same thing with Schoology. So I've got I've got an Anglican school and a Catholic school at the moment that are running in Schoology. So it's the same as this, just a different tool, because everyone wants to block everyone. Okay, so if we go into there, and we'll go into topic 2. Alright, so there's 2 videos here for students. So this one talks about the for loop, and the next one talks about number ranges. So the students again,
In this video
it's a bit loud.
tutorial, we're going to be looking at iteration. In Python, that's known as looping.
So we'll skip through a little bit. So they can independently watch the videos, look at the materials, attempt the questions, get that immediate feedback of whether it actually drew the shape or not, and correct their code. So they can work independently.
So when